This is applications of three variable systems. So remember on the last notes, I showed you guys how to solve these matrices using your TI Inspire. So that's what we're going to do in the first two examples, is to practice using that skill. So when we look at some word problems, you're able to first identify the variables, set up your system, and then once you have your matrix, you could just plug it into your calculator. So the first thing we're going to do is turn this into a matrix. So remember, we are looking at only the coefficients in front of all the variables. So we have 4, 4, 1, 24, 2, negative 4, 1, 0, 5, negative 4, negative 5, 12. Okay, so if you follow the steps and you put this into your calculator, remember in your calculator, after you do menu 7.5 to solve and type in your matrix using menu 7.1.1, you need to select 3 rows because there's 3 equations and 4 columns because there's 3 variables and 1 equal sign. Once you do that, you'll get x, y, z is equal to 4, 2, 0. Example 2, first we put it into a matrix. And remember, it's all of the coefficients in front of the variables. And we always double check that the variables are in the correct order. Then we plug it into our calculator using those same steps. And what you should notice is that when you put this into your calculator, you're not going to get that perfect identity function, meaning you're not going to get something that looks like this, the 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, you're not going to get this. And what you're going to end up getting is a false statement. Remember, if we have a false statement, that means our answer is no solution. So this system of equations does not have a solution. Okay. So let's look at the first example of the application. So it says, on a trip, Duke encounters some road construction that slows him down. While he is on the highway, he can go 60 miles per hour, and through the cities, he can go 40 miles per hour. Through construction, he can only go 20 miles per hour. He spends twice the time passing the construction as he does the highway. The 270-mile trip takes 7.8 hours. How much of this time does Duke spend on the highway, in the cities, and through the construction? Okay, so here it wants us to first identify our variables. So we're going to say x is equal to the highway. That's the first one we're looking for. Then we're going to say y is equal to the cities, and z is equal to the construction. Okay. Now it wants us to write the equations that represents the constraints on the problem. Okay. So I'm going to go back to the problem and reread it. So it says, while he is on the highway, he can go 60 miles per hour. And through the cities, he can go 40 miles per hour. Through construction, he can only go 20 miles per hour. So this is setting up our first one. So this is saying 60 miles per hour on the highway plus 40 miles per hour in the cities plus 20 miles per hour in the construction. It says he spends twice the time passing the construction as he does on the highway, which means construction takes him 2 times the highway. Okay, construction, which we said is z takes him twice as time as the highway. So z is equal to 2x. The 270-mile trip takes 7.8 hours. Okay, so from here, we can say that this first equation is equal to 270 miles because each of these are the speeds that it is going through each of these, each of the highways, cities, and constructions. And then it says it takes 7.8 hours, okay, meaning to go through X plus Y plus C. This is equal to 7.8 hours. Okay. Then it wants us to write a matrix. Okay, so the first one we have 60, 40, 20, and 270. Then we have, remember, everything needs to be on the same side. So we have -2, 0, 1, 0, and then 1, 1, 1, 7.8. Okay. So then if we use our calculator, we get that X, Y, Z is equal